Hi, welcome to the BioPharma help video. In this help video, I'm going to demonstrate how you can add multiple protein sequences to the intact workflow and then identify those sequences. So in this example, we're going to look at Herceptin, and the sample was actually digested and reduced. So it was digested and reduced in a way that we make three chains. So you'll have the light chain, and then the heavy chain is broken at the GG, and it forms two different chains. So it'll break up into two different pieces. And so what we have then in our raw file is we have the mass of the light chain, and then we have the mass of the two heavy chain pieces. And so we need to get this information into the software. Now what you want to do is you actually want to bring each one of those pieces into the software as an individual sequence. So for example, here I have, and I'm in the parameters page of the target sequence matching. Now I've already added these to the software, but we'll edit it so I can show you what it looks like. So in this example, you'll see that I have just the light chain. And so I just can copy this information, paste it here, and then add it. Or I could import a FASTA file that would just contain the light chain sequence. So you can do it either way. So once you get it in here, you'll notice that you have the molecular weight of this entire sequence. Okay, so this is what the software is actually going to search when you have this molecular weight. The sample was reduced so that disulfide bonds will be unlinked. You could add static modifications at this point if you needed to, and that's done by double-clicking on a residue. And then you can add static modifications. You also have the ability to add variable modifications. You can control the number of modifications that you want the software to search. So I'm actually going to set that to do. I don't have any, so it shouldn't matter. And then you could also choose the N-glycan if it is glycosylated. The light chain is not glycosylated in this protein, so I'm going to leave that set to none. So then I hit save, and I'm going to overwrite it, and then I just hit cancel to close it. So the heavy chain, again, is broken into these two different pieces. And so here I have the FASTA file for the the FD region, which is the beginning part of the protein down to this G. And in this example, again, the disulfide bonds are reduced, and the mass is right here. So this is the mass of this entire chain. Same thing would apply. You could add static or variable modifications as needed. But let's double check and just make sure we don't have any variable, and our glycosylation is not occurring because it actually is in the bottom part of the heavy chain in the FC region. So let's save this, and then we're going to cancel, and then let's look at the FC. Let's edit it. So again, we have, this is the bottom part, so this is the remainder of the protein sequence, and in this case, our N, I can't remember the position, somewhere up in this area actually is glycosylated. So we have an option here. We can do it several different ways. And I've added in different combinations of glycosylation. So I can put these actually in here, and you could add them as static or a variable modification. But in this case, I'm actually going to remove these, and I'm just going to use our CHO database. So you could do them as variable modifications if you know the mass of the glycan, and that way the software will find it very quickly, and you'll get that label of whatever you put here. Or you can choose to do our glycan database, and when you do the glycan database, it's searching a large number, over 200 different structures, and you can actually get that information in the help documents. So if you go into the help document, you'll actually find a list of all the glycans. Okay, so once we have this in here, and we are going to have our CHO turned on, we're going to save this. You also want to check your mass, make sure your mass looks okay. Cancel this. Now, let me expand the application. So we're in the parameters page in the target sequence matching, and what we're going to do is we're just going to add all three of these to the method. So in this case, in intact analysis, you can add multiple chains. You could add multiple sequences to be searched. And so when it searches, it's going to look for these different masses. And we actually have those 3 different masses in our file. So I actually already processed the data, so let's go ahead and search this. It should just do the identification. So in this example, I had processed and deconvolved the data prior to adding the target sequence. So something that's very nice is you can go ahead and do all the deconvolution, and then you can go back and add your target sequence, and the software is intelligent enough to know that it doesn't have to start all over. So that's a very nice feature. And so if we click down here, what we see, we can zoom in on the deconvolved spectrum, and we can see that we got the light chain. So here's the light chain in the deconvolved spectra. And if you look up, you have all your ions, and it'll show you the different charge states, so you can zoom in. And this is also using, sliding window and extract, because this was isotopically resolved data. Okay, so it's actually going to do that. And if we click down here, we'll see that this one is the FD. So this peak is the FD, and then the FC, which is probably one of, I think it's the first one. And it's identifying different glycoforms of the FC. So if you remember, we do have different glycosylations on the FC. So you can see that we did get some different ones. But if you click, you can see the options here. You can see the options here. You're also able to look at mass differences from the different types of peaks. So you can see if you have oxidation, or you can see the different masses, glycosylations, and so on. So this shows you how you can, just to summarize, you can see in this example, I had, in my experiment, I had 3 different peaks because I reduced an antibody. I created the light chain, the FC, and the FD region in the heavy chain. And then I used extract to actually deconvolve the data with sliding window. And then I added, in the parameters page, on the target sequence matching, I added the 3 individual chains. Now what you cannot do is put all these together in one sequence. So if you chose, let me show you that, and I'll show you the reason why. So I could have, let's see, where did that protein sequence go? So what I could have done, and I have seen people do this, is you would say, oh, well, I'll just take the light chain and copy the light chain in. You say light chain. And then you think, well, I can just do the same thing for the heavy chain, the FD region, put the FD region in, and then I could also put the FC region, the other region. I might have the names backwards here, I always get them confused. Okay, add that. So you can't do this and expect the software to be able to identify this. And the reason is because this is the mass that it's actually going to look for. It is not going to look for the individual chains, okay? So you do not want to put those in there. So again, it's going to look for the target protein mass. So it would go into the data and look for a deconvolved mass of 72,000, not the individual chains. So that's why you have to save them as individual sequences. Okay, great. I hope this was helpful. Thank you.